In this video, I want to talk about using combinations to calculate probability. So I'm going to talk about an example where we have 5 balls in a bucket. There are 2 green balls. So I'm going to go and write this down. We have, for the purpose of this example, let's imagine balls that have numbers on them. So we have a green ball that's number 1 on it and a green ball that has number 2 on it. We have 2 red balls, so here's 1 and here's 2. And then we have 1 white ball. Okay, so all these guys are hanging out in a bucket. All right, we decide to play a game where you randomly select 3 balls. If you select exactly one green ball, then you win. Find the probability of winning this game. Okay, so the probability that we win, or the probability that we get exactly 1 green ball, will be the number of ways that we could get exactly 1 green ball divided by the total number of ways that we can pick out the balls from the bucket. So let me go ahead and write that down. And so here we go. This makes a lot of sense. What we're doing is we're basically finding the number of ways that we can win and then divide that by the total number of possible ways that you play, right? So now let's go ahead and start by thinking about the numerator. So the number of ways that we can select 1 green ball out of 3. Okay, so if we get a green ball, let's think about that. So we got a green ball. Now there's 2 different green balls that we could have selected. Right? So we could have gotten the first green ball, the one with the number 1 on it, or we could have gotten the green ball with the number 2 on it, right? And so what is that? That's actually 2 different balls, and we're selecting only one of them, right? So this is, we could write this, let me go and write this, as 2, choose 1, right? So we have 2 balls that are green, and we're only going to choose one of them. Okay, if we get more than 1, then we don't win. All right, so now from there, what happens next? So we got a green ball, right? Now what else could we have gotten? Now we're going to get 3 balls out of here, so I need to get more than just the green ball. So I could have gotten a red ball and another red ball, right? So basically I could have gotten a green, a red, and a red. Right? And the order of these doesn't matter, right? It could have been this red, that green, then this red. It doesn't matter. All that matters is that you have 1 green and then 2 reds that are in your hand, okay? And you have the green with the number 1 on it, the red with number 1, and the red with the number 2 on it, okay? And that's what was in your hand, all right? So another option is, let's see, well actually if you gotten this red ball, you could have also gotten the white ball, right? So you could have gotten a green, a red, and a white. That's another option, okay? You could have also have gotten the second red ball and then the white ball, right? So the green with the number 1 on it, the red with number 2 on it, and then the white ball, right? And basically that's the complete listing of all the different combinations that you could have gotten for the second 2 things that you picked, right? So basically I have 2 balls that I'm picking out of 1, 2, 3, right? So there are 3 balls and I am picking 2 of them, right? So I could have done the same thing if I gotten the second green ball first. I could have gotten this one, then this one. Could have gotten the number 1 and then the white, right? And these are being repeated, right? So 2 and then the 1 again. Right? So you're seeing this being repeated twice, right? This is like the basic counting theorem, where you basically look at the number of ways that you can get one outcome, right? So the number of ways that you can get the green ball, and then multiply that by the number of ways that you can get the second outcome, which is basically you have 3 balls left over, and then you're choosing 2 of them. Okay, so we both have combinations and the basic counting theorem that we're using to get this equation I've written over here. Now, when we multiply this, 2 choose 1 times 3 choose 2, I hope it comes out to be 1, 2, 3, 4, 5, 6, and it will. So we'll show that here in a minute, right? So the number of ways I can select 1 green ball out of 3, it should be 6, and this is the way we would calculate this in case you have a more general problem where you're not able to actually list out all the different possibilities. Okay, now the denominator here, the total number of ways to select 3 balls from the basket, or from the bucket. This is, we have, let's see, how many balls are there? Well, there are 5, and you're choosing 3 of them. Okay, so I'm not going to list out all of those, but it makes sense that we have 5 balls, we're choosing 3 of them, so the total number of ways that you can select the balls from the bucket is 5 choose 3. Now, this is combination, not permutation, because the order of the balls doesn't matter, right? If you get the green, red, red, the same thing as getting a red, green, red. So, all that matters is at the end of the day, you have exactly 1 green ball. Doesn't matter if you picked it first or you picked it second or you picked it third. All right, so let's go ahead and calculate this. To remember, I'm going to go and scroll down. So remember our formula for combinations. So n choose k, the formula for this is n factorial divided by k factorial n minus k factorial. Okay, so 2 choose 1 would be 2 factorial over 1 factorial, 2 minus 1 factorial. Okay, 3 choose 2 would be 3 factorial, 2 factorial, 3 minus 2 factorial, and divided by 5 factorial, 3 factorial, 5 minus 2 factorial. Okay, so let's continue to solve this. 2 times 1, right? That's what 2 factorial is. And we have 1 times 2 minus 1 is 1. Okay, so this is being multiplied by 3 times 2 times 1. That's what 3 factorial is. We have 2 factorial. Okay, and then on the denominator here we have 1 factor, or 1, right? So 1 factorial is just 1. All right, so then on the denominator we have 5 factorial, which I'm going to write 5 times 4 times 3. I'm going to leave that as a factorial because that will cancel with the 3 factorial down here. And then 5 minus 2, or that should have said 5 minus 3. Right? So 5 minus 3 is 2 factorial. It's 5 minus, so n minus k. So k is 3, not 2. So 5 minus 3. So that is 2 factorial there. Okay. So let's go ahead and scroll down a little bit more. So this cancels. You're left with 2 times, this cancels, 2 times 3. Good. We have the 6 in the numerator that we were expecting. This cancels. This is 20 divided by 2, which is 10, right? So then we end up with 6 over 10, which is 3/5. So the probability that you win this game are 3/5. So, your chances of winning are more than half. So that's pretty good. It's a good game to play.